So Fernando's going to walk us through in the next 15 minutes some accelerometer data. We may touch upon some of our speech data, and then we'll get some cell data from Dr. Maxwell. Just quick letting people know, I know we're not taking breaks in between here. There's water bottles in the back. The restrooms are right outside the door here. So thank you, Fernando, for walking us through this.
Thanks, Rob. Thanks, everybody, for being here. Thanks, Steve. Everybody's making me sound much smarter than I am. And I work much harder than I do. I do work hard, but a lot of it, anything that I do is because of the work that my team does. We've got a pretty amazing team that carries the lion's share of the load, so I just want to make sure I can say that. Again, thank you all for being here. This is probably the first time I've ever spoken at one of these where I'm not going to be talking about mice. I'm talking about people today. So I'm going to be talking about the precision medicine program and specifically clinical outcome measures. So what is a clinical outcome measure? It's a measure of a disease symptom or a disease condition that affects the function of the person living with that disease. I have a cold right now, so a clinical outcome measure might be the number of times I have to clear my throat up here or cough. But what I'm going to be focusing on today is mostly accelerometer work that Steve mentioned earlier today. I also have an entire presentation worth of slides speaking about voice sampling as well. I do not think I'm going to have time to talk about that. I've already asked Rob to give me a webinar or something so I can go through those slides, but I will touch on that a little bit today. So you've already seen a slide that looks a little bit like this from Steve earlier today, giving you a sense of the different attributes that go into the precision medicine program at ALS TDI. Genome sequencing, blood-based biomarker discovery, we're capturing ALS functional rating scale, ALS-FRS data. We're collecting tissue samples for cellular material that Michelle Maxwell is going to tell you about after me today. It's really interesting stuff. I'm going to focus on the accelerometer data, and I'm going to touch on voice sampling data. So accelerometers, what do we use these things for? We're using them to measure physical activity. And that makes a lot of sense in a disease like ALS. We're talking about a neuromuscular disease where ultimately the patient gets weaker and paralyzed. So why wouldn't you want to capture information about how well that person can move? So who are we involving in this initiative? Precision medicine program participants. We have sort of a 1.0 version and a 2.0. Basically, we're taking enrollees in both of those programs for this purpose. What are we using? We're using these actigraph accelerometer devices. What Isaac Newton told us a few hundred years ago, that in order for something to change its velocity, you need to apply a force to it. This device is basically a device that can measure the force that's applied when you're changing your velocity, which is acceleration. It's the same thing that's in your iPhone. If you pick up your phone, you flip it, it kind of turns. It's the same technology that notices that. Like Steve said, it's the same technology in your Fitbit. So basically, we're sending patients Fitbits on steroids. There's 4 of them. Where does this all happen? This particular part of the program comes to you. So we're sending these accelerometers to participants for 1 week out of every single month, and we ask them to wear the devices as much as they can. Some participants basically wear them 24 hours a day for the entire 7 days of that week. Others wear them a little bit less. One of the things that we ask everybody to do, and everybody does do, except me as a healthy control, I'm completely non-compliant. We ask them to use specific exercises, and I'll show you a little bit about what that looks like later. Why are we doing it? Well, like I said, it is particularly relevant to people living with ALS to learn how well they can move. So that makes a lot of sense. These measures are objective measures. These devices don't have an opinion. They're not judging whether your handwriting is legible or not, and that's relevant because I'll get to it later as far as ALS-FRS. And it's easy, and the things don't break. So it made a lot of sense for us to do it. And like I said, we're capturing total activity for people who are wearing them throughout the week. We're seeing how much are you basically moving around. I talk a lot with my hands, so it captures me constantly fidgeting like this. And if I had a pinched nerve, like a friend of mine, maybe it would notice that I wasn't moving my arm as much. And we do have specific exercises that we're asking people to do, and we're comparing all of these data to the functional rating scale data that are coming through from each individual who's participating. So we have 5 prescribed exercises, and I'm going to focus less on sort of the free range element of the program where we're capturing all of the movement, and more on the exercise protocol today. Specifically, I'm going to focus on the right arm raises, but that's neither here nor there. I'm going to embarrass my friend and colleague who I've worked with for almost 15 years, Kenneth Thompson, with his performance of the exercise video. Oh, this is the standing still part. I had to do this too, you know. People laughed at me. So he uses right leg extensions, and then he'll do left leg extensions, and then he pauses in between.
How long should you do that?
For 45 seconds. Great question. And then we ask people to do as many as they can during those 45 seconds with as complete a range of motion as possible. So these are the right arm extensions, and I'll be showing you specific data of these. And then left arm. And then, let's see if I land on it. I just made this up. Seated trunk crunch and recover. Seems right, doesn't it? So what are we comparing this to? So I mentioned earlier, and Steve mentioned earlier, the ALS functional rating scale, so ALS-FRS. What this is, if you're a person living with ALS or a caretaker or somebody in the family or a clinician who treats people with ALS, you've seen or administered this. It is a survey where it actually makes a lot of sense in some ways because the questions that are asked are things that all of us do in our lives. I carved out 4 of the 12 questions that make up the ALS-FRS for this purpose because these are focused on upper limbs, and I'm going to be comparing to the arm exercise data for you. But I wanted to show you what these questions are to just kind of point out some of the issues that can arise from using this metric. And I'm not bashing the metric, I just think there are some weaknesses to it. So the way it works is for each question, it's a scale of 0 through 4. Normal functionality gets you a score of 4. So if you have normal handwriting and you can cut food normally, those would total to 8 points, right? Now if you go down, slow or sloppy, all words are legible. Not all words are legible. Well, legible in whose opinion? You look at somewhat slow and clumsy for cutting food, but no help needed. Well, that's kind of like my 6-year-old son, right? Unless I'm in a rush, in which case he certainly needs help when I cut it all for him. So all of these are somewhat subjective, and there's risk in that. And one of the other issues is, so this would be a score of 3, and this would be a score of 2. There's no 2.5. There's not a something in between. So there's information lost in that decision between one point and another. So we hope that metrics like accelerometers, and there are other approaches being taken too, can sort of smooth out that hop. Sorry, I just shot you a little late. Smooth out that hop, and also maybe take out some of the subjectivity in the way we're looking at clinical outcome measures in ALS. So I'm going to walk you through 2 patient case studies for participants who are enrolled in the precision medicine program at TDI to kind of illustrate some of the value that we're getting from this. I'm focusing on upper limbs, and particularly the right arm exercise component. So for participant 153, this person joined, I think, the program, I want to say January 2015. And what you see here is on this graph, you're seeing plotted both vector magnitude, which is an accelerometer data outcome, for the right wrist, and we're seeing the value go down, meaning there's decline in that functionality, and I'm going to drill into that a little bit. And we're also seeing for the upper limb FRS, so the arm FRS, we see a decrease from 8 to 6 to 1 over a 13-month period, and those data move in lockstep. So this patient makes a lot of sense to us. Now, participant 62, it's a little bit more confusing. We see an arm-related FRS and an overall FRS, frankly, that stays pretty flat. But we start to notice a decline in the vector magnitudes for the person participating, doing the exercises with the accelerometer. So what is this telling us about this person's experience with ALS? What can we learn? So I'm going to walk you through how kind of these differences inform us and take you through what we're learning from each patient. Starting with participant 153, you can see the types of data that can be extracted, and this is work done by a young man in the lab, Alan Primaseri, super bright. I don't want to call him a kid, he's a grown-up, but he's amazing. He figured out how to extract with the help from Ultian and Moscow in the back. Oh, they're hiding in the back. Raise your hands. They extracted these data. And what you're seeing in this nice little sine wave for each of these is the actual velocity, how fast that accelerometer was moving while they did the exercise. And it makes a lot of sense where you have zeros, right, for some of that repetition. You go, you come to a stop. You come here, you come to a stop, and your fastest speed is in the middle. So you see the peak velocities both going up and down along the way. And in January 2015, this participant was around sort of 3 to 4 meters per second. And then in July, they had declined very much down to about 1 meter per second for peak velocities. And then here in February 2016, they're struggling to do the exercise at all. And this does make sense when you think about those FRS score answers to those questions. If you're down near a 1, it means you're not cutting food yourself. You're not able to write. You're not able to dress yourself. So this, again, is the circumstance that makes sense. You can further derive from these data the distance moved for each of those repetitions. So I just described this. You know, a full range of motion in sort of that arc turns out to be about 3 meters. That actually makes sense for an up and down. This person was, by the second time point, that's 6 months later, then they were down to sort of a single meter, so sort of 1.5 feet. And now here the range of motion is very, very limited, and the number of reps decreased for that 45-second period. So we're seeing clear disease progression in participant 153. Now, participant 62, a little bit different. You might notice a lot more repetitions in all cases, but we are still seeing progression, right? So the peak velocities started out higher. They were at about 5 or 6 meters per second. They go down to about 3 or 4 meters per second, and then down to about 2 or 3 meters per second. So we're seeing a decline, but again, no decline in the ALS FRS. When you take it one step deeper again, and we look at the distance for each repetition, we see a decrease. We see more repetitions. So what that's actually meaning is this person, they're trying hard, right? But they can't get the whole range of motion. Maybe they're just down here. Maybe they're just using their arm a little bit, and they can do a lot of them. And when you now think about that in the context of these questions, So handwriting, cutting food, dressing and hygiene, turning in bed. Maybe the limitation that we're seeing from the accelerometers is pathogenesis affecting the deltoid muscles, rhombus, and your ability to do an arm raise. But the person can still write. The person can still cut. So this is not to say that ALS-FRS doesn't have value. It's saying that there may be complementary data sets that we can get using accelerometers that tell us something different and that have a lot of value as well. But I do want to bring your attention to one of the risks with ALS-FRS alone. So if this person, if ALS-FRS is your only endpoint and this person is in a control group of a clinical trial, they're going to look like they didn't get any worse. It's going to be hard to see a drug effect in a treatment group against that as your placebo control. And vice versa, if this person is in the treatment group, it might look like they were getting a benefit because they didn't progress, when in fact some part of them was progressing, and we're losing that information. So to the question that Ted asked earlier about whether the precision medicine program aims to sort of find solutions that might end up reducing trial size and increasing the power to detect effects. Yes, that's what we're trying to do. We and others, and we collaborate with others on this type of work. In fact, I'll get to it in a moment, but we're working very closely with Denali Therapeutics on the West Coast on this particular program. They have a lot of smart contributors to this project, actually. So what can we conclude from the accelerometer work that we've done? I didn't go into this, but we did all kinds of experiments on how reliable are these things, and it was kind of fun because we were throwing them in the air and testing how well they did relative to gravity and stuff. We also, I can tell you all about that another time. We have some cases where accelerometer data really correlate very strongly with self-reported ALS-FRS data. But we have some instances where they tell us a different story, and that's very interesting and important to us. And ultimately, we hope that these technologies can be valuable tools for reducing ALS clinical trial sizes, durations, and the risk of false positive and false negative in our trials. So that's the accelerometer program, and I definitely need to, first of all, thank all of the patients who have been involved with the program, specifically in this case, 153 and 62. But thank you. Alan and Altiana for all the hard work they've done. Sean, Ben, Bashar for getting all of the software tools together for us to do this, with the entire clinical team around the program. The in vivo team, they're my family. The translational research, they've joined the family. And the Denali folks, Carol, host, Sophia, and James. So thank you. So this is the coda. Voice sampling, I'm going to blow through and just say we have probably about 6,000 audio files at this point. We've tried to figure out how to rank them. We don't have all the computational power necessary to do it. They do. So we're going to give them and then work together. So that's the idea. And some lots of thanks again.
So I'm gonna leave that slide up so all you guys can copy down that phone number, because everybody in the room can, besides help us reach $40 million a year so we can put one drug that's well validated using these tools in the clinic every year. You can help with research, call that number at the top. Text it to yourself right now. It's a really important part of the precision medicine program. Your voice data will be used in that collaboration with Google. That was announced literally for the first time today by Dr. Perrin earlier and Fernando now. So we're really grateful to have them as partners. And you can have your data go to Google in that way and help us find a cure for ALS by calling that number. We have time for 2 questions. So one from online, and then Jess has got the microphone, and we'll come to you.
It is what is involved in getting physical device measures accepted by FDA for trial measurement.
I don't know what is involved in getting it done, but I know it has been done. So the specific devices that we're using today, so these actigraph devices, one of the reasons we picked them is because they have been used in clinical trials for Parkinson's disease and maybe another indication too, Steve. Do you remember? There's another. Yeah. So it's doable. The solutions exist.
I know we already have more data than we can handle, but, what about, entering on the portal at what times you're eating, and you can actually measure your exercise movement during a mealtime and compare that to FRS?
So you try get closer where I can see you.
One of the things on the FRS is how long you feed yourself.
Yes.
What if in a portal you want to enter the time at which you're eating?
Oh, I
And
see.
you look at the physical argument while you're supposedly eating.
That would make a lot of sense. Another end. No, it would make a lot of
And
sense.
that was the portal, and that was
It's a more objective measure for how well. That's a good idea. Thank you.